I'm going to start on a new page. So here's our proof. So proof that the sum as k goes from 1 to n of k squared is n plus 1, 2n plus 1, thank you, all over 6. Okay. We're going to do something that's really sort of fun. We're going to start with the sum of k plus 1 cubed minus k cubed. Why, you ask? Because I said so. And here's how we're going to start. So we're going to back into this two ways. So first, let's actually write out some numbers. So can you do some plugging in, please? Jackie, just plug in 1. What's that going to give us? Okay, in fact, don't multiply out. So that's going to give us 2 cubed, right?
Yeah.
Minus what here?
2 cubed.
Well, k is just 1.
Oh, 1
So, right, so that just becomes 1 cubed. Okay, now let's move up, Jackie, to where k is 2. So what's that going to give us?
3 cubed plus 2 cubed.
Minus 2 cubed. Good. Let's move up to k is equal to 3. What's that going to give us?
4 cubed.
Mm-hmm.
Minus 4 cubed. Minus 3 cubed.
Right. So you begin to notice a pattern. What about, Jackie, if k is 4?
5 cubed minus 4.
Good. And the next one would be what?
6 cubed minus 5.
Good. And we're going to keep on going, right? And we know that our very last term is going to be, well, we're going to be plugging in n. So for our very last term, what are we going to have? Jackie? Okay, n plus 1 cubed minus n cubed. But what's going to happen with all of these? So tidy that up a little bit. Eric, what can we just get rid of?
All I have stuff since many of them cancel out.
Yeah.
2 to the 3rd.
Good. Yeah, so these are going to cancel. And notice kind of the pattern. 5 is going to cancel with the 5. Is this 6 to the 3rd going to cancel with something? Yes. That's going to cancel with something. And what about this n to the 3rd? Is that going to cancel with something?
No.
Actually, it is, because the previous term, so I didn't bother to write it in, but you know, the previous term must have been, well, 1 lower than this, n cubed minus, and then the term before this would have been, I don't know what it is, but it's n minus 1 cubed. So the n cubed would have canceled. Would this n minus 1 have canceled with the term before it? Yeah. So the only thing I have left over here is n plus 1 cubed minus 1. So after all that simplifying, this is what I get. And here's a little something that you probably should know. Let's simplify that a little bit more. Does anyone know the expansion for n plus 1 cubed in his or her head? Marie?
N plus 1 times n squared minus n plus 1.
No, what you're doing is factoring n plus 1 quantity squared. But let's go with, we know it's going to be n plus 1 plus n squared plus 2n plus 1, right? There's n plus 1 squared. So that gives us n cubed. We get 3n squared. We get 3n. We get plus 1. And then we have this minus 1 from before. So after all of this, what's this simplifying into? What's this simplifying into? Zach?
Is it n cubed plus 3n squared?
Uh-huh, exactly. The ones cancel out. So n cubed plus 3n squared plus 3n. Okay, end of story. So that's all we can do. But let's look at this another way. So here's the other thing we could say. Also, let's go back to where we started. We had k plus 1 cubed minus k cubed. And we were looking at this as k went from 1 to n. And I'm going to do a little bit of work on the inside here, because I know that this k plus 1 cubed, as we just discovered, I could rewrite as k cubed plus 3k squared plus 3k plus 1, and then we have that minus k cubed hanging off. So, James, tidy up inside this set of parentheses. What can we get rid of? So now what we're doing is we're just taking the sum as k goes from 1 to n of 3k squared plus 3k plus 1.
Wait, how did you get that second row?
This, all I did was I multiplied out k plus 1 cubed, and then I subtracted the other k cubed. Alrighty? All right, now let's keep going, because we, in fact, now have some properties. Can I split these three terms up? Jeffrey?
I'm sorry, can you just wait a little bit? I have to.
Yes. Okay. But just think about this. Can I split those three terms up? Zach?
How'd you get the, or is that just, that's the original equation?
The k plus 1 cubed minus, yeah. And it is a good question to say, why did we start with that? Because you don't know. Okay. Okay, so can we split these up? Jake?
Are we still proving?
Yep.
Is this all gonna tie together?
Yep.
All right, got it.
Okay.
Trust you.
Okay, thank you. Can we split these up?
Yes.
Yes.
Okay, so let's do that. So I'm going to write this. Now, when I split them up, can I factor the 3 out of this k squared?
Yeah.
Okay, so I'm going to do that. So I have 3 sum of k squared plus 3 sum of k plus sum of 1. And now let's do what we can. The sum of k squared I can do nothing with because we don't, that's what in fact we're trying to derive. But what about this one? This middle term, we have, in fact, I'm going to come on to another line. 3 sum of k squared plus 3 times, what can I replace this middle sum of k with? What's that formula that we just did? You might want to look back through your notes. What is it? Yes, exactly. Good. So that becomes n over 2 times n plus 1. The other thing we have is we're looking at the sum of 1, right? K goes from 1 to n, and 1 is a constant. So what can we do with a constant? It's just 1 times n. So that's just 1 times n. Okay, so we're expanding this. Okay, now let's tie this together, because you know what? Earlier, up here, we had done all of that work. We know what this is going to be. Earlier, we said that's going to be n cubed plus 3n squared plus 3n. So now we just have a little bit of algebra to do. I'm trying to solve for this 3 sum of k squared. I'm trying to solve for this. So let's clean this up a little bit. So this becomes 3 sum of k squared plus, I'm going to write this as 3n squared plus 3n all over 2 plus n equals n to the third plus 3n squared plus 3n. I want to get rid of the fractions, so I'm going to multiply everything by 2. And Caleb, can you do that for me? Distribute. What's this going to give me?
6 sum of k squared.
Right, 6 sum k squared. And then over here, what's going to happen to those 2's?
The 2's going to cancel.
So what are we left with?
3n squared plus 3n.
And then what?
Plus 2n
And then what?
equals 2n cubed
Mm-hmm.
plus 6n squared.
Mm-hmm. Plus,
It's cut off.
sorry, plus 6n. Okay, so looking good. I'm trying to solve for this. So let's move everything else to the other side. So in fact, the 3n plus the 2n, that's 5n. Okay, Vivian, would you continue for me? So let's leave the 6 sum of k squared on the left-hand side. But on the right-hand side, we're going to have 2n to the third. How many n squareds are we going to have?
3.
Good, because we're subtracting 3n squared from both sides. How many n's are we going to have?
6.
But then let's subtract that.
5n out, so then
Good, plus 1. And I need to go on to another page. So let's do a little work on this right-hand side. What can I factor out? Oops, plus 1n. What can I factor out of each term? An n. So, come on, come on. Okay, so we have 6 sum of k squared. Well, let's factor an n out. So we have 2n squared plus 3n plus 1. Can you factor that a little bit further? 2n squared plus 3n plus 1. Can that be factored? 2n squared has got to factor into what? Yeah, 2n and n. In fact, let's make it n and 2n. n, n times 2n. And 1, there aren't a whole lot of factors for 1. That has to be plus 1, plus 1. And does that work? 2n squared plus 3n plus 1. Does it factor into n plus 1, 2n plus 1? And there's our 6 sum of k squared as k goes from 1 to n. So therefore, we've done it. So that's going to give us n times n plus 1 times 2n plus 1 all over 6. And there we go.